Hello guys again. So now we are trying to build this circuit, which is the third part of our lab. The second part I will leave it to you at home to do it. Um, this circuit is a little bit complicated in the file lab because of the ammeters. Now I will show you how to make it without the ammeters and then how to add the ammeters to take the measurement. Okay, so we go to multisim. Here it is. We need 3 resistances. We can take them like that, or we can take one and copy it, doesn't matter. And we want one source, DC power source, here's the guy, and one ground, here it is. So the current is going from the source to this resistor, which is connected through this node into these two. Okay, so the current goes like that, and in this node it is going to branch up and down, and then it is going to go back to the negative part of the source from this side. So what does Kirchhoff current law say about this? It says the current that goes through this branch when it reaches this node is going to equal whatever current leaves from this node. We have two currents that are leaving, one is up, one is down, and we want to see that. Is it really the case or not through this simulation? Now to do that we need a current meter or current meters. So we want to measure the current that is coming from the source, and we want to measure the current that's going through this resistor or this branch, and we want to measure the current that goes from this resistor or this branch, right? As we mentioned in the cast before, to measure current we have to break in the circuit, to make a break in the circuit. So I put this guy here, then we break this one so the current can be measured. The same thing goes for this one. Now maybe it would be more logical to flip this guy here like that. Oops. One more. And so I want to measure this current that goes like that. So I will take these and then break this circuit like that. The same thing here, I want to measure this current. It doesn't matter whether we put the ammeter here or here. So put this guy here, and break the circuit so that the current can pass, become measured, and go back. Now there are 3 different values in the lab files. I will take just 5 volts for instance, and this is the ammeter which measures the current that goes in. This is one of the currents that goes out, and this guy one of the currents that goes out. Now we have to be careful about something. We need to be careful about the polarity. So the current is assumed to go in. If we go into the positive of the ammeter, it is going to read a positive value, and we are assuming that the current is leaving from here, which is logical because we don't have other sources. So this is going to read a positive value, while this guy, the current is going into the negative part, so it is going to measure a negative value. If we want to be consistent, maybe I can remove this and remove this and put this guy here while this guy goes here. That's okay. The circuit becomes a little bit clumsy, but doesn't matter. You understand the point. Actually, it is good to see the point. Now if we run this simulation, we see that the input current which is going into the node is 3. Oh, sorry, those are voltages. Okay, so we are measuring currents, so I'll just change things to currents. Okay, so the input current that goes into the node is 3.33 milliamps. The current that leaves here is 1.667 milliamps. The current that goes here is 1.66 milliamps. If we add these two up, they should give us this one. Okay, if we change this value, just to make sure, maybe we take some even number, let's say 6, and run the simulation. we get 4 milliamps here, 2 milliamps here, 2 milliamps. So these two add up to give us this one. This one goes in, these two which go out. So as you see, this is the idea of Kirchhoff's current law. The current that goes into the node equal the currents that goes out of the node. Of course, we can have different currents going in. Whatever the summation of the currents that go in should equal the summation of the currents that go out. Thank you for watching. See you tomorrow in the lab.